Hello and welcome to another one of these ADD videos. Today we're going to be looking at U substitution. We're going to be looking at more advanced scenarios. Again, we're going to try to take the derivative of one part, make it look like the other. We only care about the fundamental part of it, not the exponents, square roots, denominators, whatever the case may be. And when we derive it, we should get what's left in the problem. The same number of x's to the same power. And after that, you're going to assign U, derive both sides, solve for dx, plug in, integrate, or cancel, and then integrate. If you don't get rid of the x's, you can't do U substitution. And then plug back in what U equals. Alright, so let's look at a problem. Let's see, let me make a problem here. I don't know if this is enough space. I'm going to zoom in a little bit, that way we can get a little bit more space out of what I have left on this page. So let's look at this integral here. Let's do the integral of x over x plus 1 dx, and we'll make that squared. Alright, so the first thing to do is normally we would let U equal the more complex one without the exponent or the denominator. In this case, you get du equals dx. The integral then, when you solve for it, becomes x that we didn't do anything with. The denominator is your u, and it's squared, so that's what you have there, and then du equals dx, so you can plug in a du instead of the dx. Now I've always told you that in U sub that you got to get rid of all of these guys right there, okay, and that x is staring you in the face. So either you did something wrong, which we didn't in this case, or you can't do U substitution, or it's one of these scenarios in which you can take this expression for U and x, the relationship between U and x, and then solve for x. Once you solve for x, you plug it back in and get rid of that x that's in your problem. So here, if I subtract 1 on both sides, you get U minus 1 equals x. So if I plug that in for that, I no longer have x's. Hopefully I have a problem that I can integrate, and sure enough I do. At first glance you might be intimidated, not know what to do, but then you remember your algebra and you remember that these two things in the numerator were once separate entities, so you can take them and separate them, and then just use some algebra rules to simplify. This becomes 1 over U, and then 1 over U squared. Nope, running out of space there. Still integral, still du. So we would need to make it integral of U to the negative 1 du minus U to the negative 2 du, which equals, first one, when you add 1 in the process of integration, you get negative 1 plus 1, which is 0 over 0, and that should tell you right away that that's not how you do that one. That's a special scenario. So then what is the object that you derive to get du over u? Well, that's, by definition, natural log of u. Alright? And then if I add 1 to this one, you get a negative 1, so that becomes plus u to the negative 1, and then plus the constant. Okay, so here we have u is equal to x plus 1, I believe it was. So this would be your final answer. Alright. Let's look at another one. This one I'm going to have bounds. I want to show you how to change your bounds if you're given a u-sub problem, because once you do your substitution, the initial bounds that you had were only for x, not for your u's, so you got to change it. So let's do e to the 4x dx. Actually, let's make that a squared and put an x there. Okay. If you guys remember, I didn't cover this in the other video, but e to the number x is a u-sub problem. You're letting u equal the exponent, and then du equals the number dx, and you divide by the number, substitute and integrate, and when you do that, you get that equals e to the number x integrated equals e to the number x over a number, as long as that power of x is 1 always. Alright, so this is a rule that I just tell people to go ahead and memorize. There's no need to do all these steps right here, as long as you know this wonderful little rule right there. Okay, but in this case we have an x squared expression, and when we solve that, we got to do u sub. Oh, I said I was going to give some bounds, so let's give some bounds. Let's go from 0 to 1. Okay. So if that were the case, again, if you have one e in your problem, you always let u equal the exponent if you can do u substitution, and du should be what you have left in front. In this case, an x term is what we have left in front. So yes, that is doable. Solve for dx. And then you get a new integral, x e to the u du over 8x. This is the x that was in the problem originally. We didn't do anything with that. And hopefully when we get to this point, it cancels. Okay. Now, for me to put a 0 and a 1 there would be incorrect. That would end up putting x bounds in a problem that was for u's. So what we do is we come over here to our relationship, and by coincidence, they're going to give you, oh no, not the first one will be 4 times 0 squared, and by coincidence the u value is the same thing as the x value. I'm going to write that in a different color somewhere else so we can see that. So if I were to, let's go over here, if u equals 4x squared and x equals 0, by coincidence you get u also equals 0. But if u equals 1, u equals 4. Okay, so those are the bounds when it comes to u's. So 0 to 4. And the integral of e to the u, so this is the problem that we have now, which is much more doable than the first one. So in this case, e to the number u, where the number is 1, would just be e to the u answer. And we would evaluate it between 4 and 0. And you do the top bound as always, minus the bottom bound plugged in, and anything to the 0 is 1. And that would be your final answer. Okay? So what it allows you to do is, normally there would be a step in here in which you'd plug back in and you'd get e to the 4x squared. But when you change your bounds like that, you no longer need to do that step. You can just plug in your new bounds into your answer for your integral. Okay? I'm going to try to squeeze another quick one in. This one is if you have two e's. If you have two e's, you want to let e equal the more, or u equal the more complicated one. So here we have we'll make this one cubed. U equals e to the 2x plus 9. Du equals e to the 2x over 2 dx multiplied by the reciprocal on both sides to get dx by itself. I'm going kind of fast here, hopefully you're keeping up. We've done enough of these that you should be able to see what I'm doing here. And then e to the 2x's cancel. So then you get a negative 1 over u squared, and u was e to the 2x plus 9. Okay? So you should be able to flow through these pretty smoothly once you get the hang of it. So the main way to be able to achieve that smoothness is to practice, practice, practice. I say it on every one of my videos, and it's just as important as reading and learning the stuff, or if not more important, is to practice it and see if you can actually apply it. Alright? Hope this has cleared up things for you. Sorry about the longer video than normal. Thank you and have a nice day.